Hello students, in this unit we will discuss about the use of measuring instruments. By the end of this unit you will be able to know about different measuring instruments. Measurement. Measurement is the comparison of one quantity with standard quantity. The following values can judge any measurement. Level of measurement, which includes magnitude, dimensions, uncertainty. Measurements are commonly made in the SI system, which contains fundamental units like kilogram, meter, candela, second, ampere, liter, and mole. What is a unit? A measurement unit is a definite magnitude of a physical quantity, length, mass and time. Example: 10 liters, 200 meter, 20 kg. These are commonly used systems for measurement. CGS, FPS, MK. Nowadays, SI unit is used worldwide as a standard system of measurement. It is an extension of the MKS system of measurement. Measuring instruments. A measuring instrument is a gadget for measuring a physical amount. It shows the extent or amount or quantity or degree of something. Classification of measuring instruments. Precision instruments. Precision instruments are those which can measure with an accuracy of 0.01 mm or more. Example: vernier capillary, micrometer, etc. Non-precision instruments. Non-precision instruments are used for measurement of parts to visible line graduation. Example: steel rule. Least count. The minimum tally of any measuring hardware is the littlest amount that can be measured precisely utilizing that instrument. Least count shows the level of precision of estimation that can be accomplished by the measuring instrument. Steel rule. Steel rule is a flat and thin linear measurement instrument. Steel rules are available in different sizes like 150 mm, 300 mm and 600 mm. The reading accuracy is around 0.5 mm. There are different types of rules available. Few commonly used rules are engineer's rule, folding rule, flexible rule, hook rule. Vernier caliper. A vernier caliper is a precision measuring instrument used to measure the inside and outside diameter of shafts and thickness of parts with an accuracy of 0.02 mm. These calipers consist of a calibrated scale with a fixed jaw and a movable jaw with a pointer. For using vernier caliper, move the position of the pointer on the scale. At the point where the pointer is between two markings, take the reading on the scale. Parts of a vernier caliper. Outside jaw to measure the outer diameter and width of an object. Inside jaw to measure the inner diameter. Depth probe to measure the depth of an object. Main scale, scale set apart in millimeter. Main scale, scale set apart in inches. Vernier scale, interpolated estimations in millimeter. Retainer used to lock the movable parts. Using and reading a vernier caliper. Step 1. First, lose the locking screw of the caliper and check the vernier scale for its proper working by moving the slider and ensure the caliper is reading 0 when closed fully. If you find the caliper is not showing 0 reading, then adjust the jaws of the caliper till that you get a 0 reading. Step 2. Close the jaws delicately on the object which needs to quantify. Step 3. The main scale on the vernier caliper typically tells you the whole number plus the first decimal. Read this just as you would a ruler, measuring to the 0 mark on the sliding scale. Step 4. Find the first mark on the vernier scale that lines up perfectly with any line on the main scale. That mark tells you the value of the additional digit. Step 5. Add the main scale and vernier scale results together to get the final answer. Make sure you use the correct units and label on each scale. Micrometer. A micrometer is a gadget assimilating on a line screw broadly utilized to estimate the segment in mechanical trades and machines. They are used to measure very small distances. Parts of a micrometer. Frame. The C-formed part that clamps the anvil and barrel is steady connection to each other. Anvil, the gleaming part that the spindle pushes towards and the model leans against. Sleeve, barrel, stock. The stationary cylinder part with a straight scale on it. Lock nut, lock ring, thimble lock. The rough part or lever that one can fix to hold the spindle stringent, for example, when instantly holding a measurement. Screw. It is the main part of the instrument, stays inside the barrel. Spindle. The gleaming round part that pushes the thimble towards the anvil. Thimble. This part turns by the thumb. Ratchet stop. Applied pressure can be limited by the device in the end of the handle by slipping at an aligned torque. Height gauge. The height gauge are precision measuring instruments used to determine the height of an object or workpiece with extremely high precision and accuracy. Advanced electronic digital height gauge can carry out different tasks like measuring step height, internal external diameter, and center line distances. The electronic height gauge has a precision of up to 0.0254 mm and claims consistency of plus minus 0.00254 mm. The conventional height gauge are similar to vernier capillaries except that are fixed jaws in shaped like a base. Types of height gauge. Height gauge may be broadly categorized into 4 basic types: vernier height gauge, dial height gauge, digital counter height gauge, electronic height gauge. Feeler gauge. A feeler gauge is a tool used to measure gap width. They are mostly used to measure the clearance between two parts. They are made of several small steel strips of different thickness with measurement marked on each piece. Filler gauge are generally used for setting spark plug gaps, valve clearances and ignition point gaps in engines. Filler gauge are generally available in meter and inch grades. Dial indicator. This instrument is used to measure small linear distances. The measurement results are displayed on a magnified scale, that is a dial in the instrument. The dial indicator can also check variations in tolerances of machined part. Its typical measurement range is 0.25 mm to 300 mm. Calibration of measuring instruments. The accuracy of all measuring devices degrades over time. This is typically caused by normal wear and tear. However, electric or mechanical shock or a hazardous manufacturing environment can also cause changes in accuracy. The bottom line of the calibration improves the accuracy of the measuring device. Accurate measuring device enhance the quality of the product. Calibration includes establishing and documenting abnormality of the measured value from retraceable, externally precise standards of inspection. During calibration, the known value of an instrument is compared with the measured value under specific condition. In calibration, balancing and correction of scale reading are done to correct the instrument's deviation. Therefore, the measured value is adjusted to its known value. Why do measuring instruments have to be calibrated? Calibration of your measuring instrument has two objectives. It checks the accuracy of the instrument. It determines the traceability of the instrument. In practice, calibration also includes repair of the device if it is out of calibration. A measuring device should be calibrated according to the recommendation of the manufacturer after any mechanical or electrical shock. Periodically, the session ends here. Let us have a quick recap before we proceed to the next topic. After studying this unit, the participants will be able to know about different measuring instruments.